Good evening to one and all present here. On behalf of PG and Research Department of Mathematics, DG Vaishnav College, welcome all the CSR aspirants. Prayer is talking to God Almighty, the creator of whole universe. So let's begin our session with the presence of God. Now, Tamutai Vatu followed by college prayer.
நீராறும் கடலொடுத்த நிலமடந்து எழிலொழுகும் சீராரும் வதனமென திகழ்வரத கண்டமிழே எக்கணமும் அதிசிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை முதலும் தரித்தனரும் திலகமுமே இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம் மிகுந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
சத்யவ்ரதம் சத்யபரம் த்ரிசத்யம் சத்யஸ்ய யோனிம் நிஹிதம் ச சத்யே ருதசத்யநேத்ரம் சத்யாத்மகம் த்வாம் சரணம் பிரபன்னாஹ ஸ்ரவணோ கதாயாம் ஹஸ்தௌ ச கர்மசு மனஸ்தவ பாதயோர்நஹ ஸ்மிருத்யாம் சிரஸ்தவ நிவாசிஸ்ததாம் தர்சனேஸ்து பவத்தனூனாம் தஸ்மை கிருஷ்ணாய ரூபநாமதேன ரூபநாம क्रीडति यो यतः ॐ शान्ति शान्ति शान्ति.
Ramanian, Assistant Professor, PG and Research Department of Sir?
Yes.
Sir, you will continue, sir.
Okay. Thank you, Mr. Rajshekhar. Okay. So this is my second session. I will continue with where I left. Okay. In my last session, that is on 15th, I was discussing about, I gave the introduction about Volterra and Fredholm integral equations. What is the linear integral equation? What is the Fredholm and integral Fredholm and Volterra type? So just I gave the introduction about that, and then how we can find the solution. So that is what I gave. So just I will recall those what we did, and then we will proceed with the next session. Is my screen visible?
Yes, sir.
Thank you.
Yes, sir. Yes, sir.
Okay. So just I will give you the brief of what we did in the last class, and then I will proceed with what we are going to see today. So linear integral equation. So what is the general type of the linear equation? So the general type of the linear equation is given by v of x into u of x is equal to f of x plus lambda into integral a to b k of x comma t into u of t dt. So this is what the linear integral equation. So this is general type. Here u of x is an unknown function. So if you speak about the function, we are having u of x, v of x is there, f of x is there, and then some constant lambda is there, and then integral a to b is there, k of x comma t is there, and then u of t. Of course, we can relate u of x and u of t. So just a change of variable u of x to u of t. So we have so many functions. So v of x and f of x are known functions. So v of x and f of x are known function, and then u of x is an unknown function. U of x is an unknown function. Okay. Other than that, if you see lambda is there, lambda is a non-zero real or a complex parameter. So we are going to call this as an eigenvalue. Even we are going to find eigen function related to that. And then k is the kernel. K of x comma t is what called the kernel. So once if you want to solve a problem on this type, so here you have to remember this linear integral equation. So what is the general type? So v of x into u of x is equal to f of x plus lambda into integral a to b k of x comma t into u of t dt. So once if you remember this, then we can proceed. So as I said in the last, that is my last session, there are 3 or 4 questions we can expect on this, either in part B or part C. If we see in part B means there will be only one correct option, and then it carries a negative marks. And then part C means there may be more option. There may be it can have 2 or 3 or 4 or 1. Okay, all there is a possibility for correct answers may be there, but there is no negative marking. But based on that we can solve. So this is a general type. First you have to remember what is a linear integral equation. So v of x into u of x is equal to f of x plus lambda into integral a to b k of x comma t u of t dt. So this is what the general type. This is what called as a linear integral equation. So if we list as a type, so based on the limits. So what are the limits? Here we are discussing that a to b is the limit. So based on that limit, we can classify it as an Fredholm integral equation or Volterra integral equation. Suppose in case if both a and b are constant, then that is what called as Fredholm. Suppose if a is a lower limit, there is a constant, and the upper limit it's a function of x, b of x, then that is what called Volterra integral equation. And then again we can classify into first kind, second kind, and the third kind. So that first kind, second kind, third kind is depending on the function v of x. This depending on the function v of x. So if v of x is 0, that is called as the first kind. If v of x is 1, that is what called the second kind. If v of x is any function of x, that is g of x, that is what called the third kind. So now we know what is the general type of the linear integral equation, and then now we can classify whether it is an Fredholm or Volterra. Again I will recall, v of x into u of x is equal to f of x plus lambda into integral a to b k of x comma t u of t dt. So this is what an linear integral equation. So this will be called as Fredholm if the limits a and b are both constants, and this will be called as Volterra if the upper limit b is a function of x. And then if you see a functions u of x is an unknown function, v of x, f of x, and then that parameter lambda is known, and then kernel everything is known. So based on that we can solve. So this is what the type. So last class what we did, if linear integral equation is there, how we can find the solution. So what I did, normally since we are having as a objective MCQ types, there will be 4 options. Better we can go from the option itself, because it may be time taking process to solve directly. Of course that is also easiest. So that is what I gave one of the method as a successive approximation method. Even by that we can do, but the other possibility is from the solution we can go to the that is we can approach the problem. So 4 solution will be there, so we can choose one and then directly we can substitute whether the equation satisfies, that is LHS equal to RHS, then we can say that is a solution. So that is the way we can do. Or successive approximation means what we can do, so we have to go by iteration. So first initially what we'll assume, either 0 as a solution or 1 as a solution or x as a solution. That is my first successive approximation. So we have to go by successive approximation, iteration, step by step. So what I will do in the first initially I will choose either 0 as a solution or u of x, that is u naught of x as 1 as a solution or x as a solution. So with that I will proceed. So my first approximation will be u1 of x, just I'll be writing here. So my first approximation will be u1 of x is equal to f of x plus lambda into integral whatever a to b kernel k of x comma t and then u naught of t dt. So based on this we'll be finding, so this is what the previous iteration. So initial what assumption we are doing based on that. Similarly what we'll be doing, we will be finding what is u2 and then what is u3 and then successively u4. After that what we can what we will find, it will follow a pattern. So from that pattern we can say that this will be the solution. This is one of the method what we discussed. So this is again one of the possibility. So today what we are going to see, so in case if differential equation is given, how this differential equation can be converted into linear integral equations, either Fredholm type or Volterra type. So this is what we are going to see in this session. Sir, how we can classify that differential equation is given? How we will be knowing that whether we will be getting Fredholm or whether we will be getting Volterra? How we can identify that? So based on the boundary conditions, we can identify that. Based on the boundary conditions, what is given in the problem, based on that we can identify whether it is a Fredholm or Volterra. So if Volterra means what we need, it's a general. So that means if it is an initial value problem, that will be on Volterra, and then if it is an boundary value problem, it is a boundary value problem means that will be of Fredholm. Boundary means it will be given like y of 0 to y of 1, like that it will be given. In initial value means it will be given only on the initial. What is the initial point? We'll choose y of 0, y dash of 0, like that. Suppose in case of Fredholm means it will be given like y of 0, y of 1. That means we can say that 0 is the lower limit, 1 is the upper limit. That means 0 to 1. Suppose if I say that 0 to 1 is the limit, then constant limit is there, then I can say that is a Fredholm. So this is how we can identify whether I'm going to get a Fredholm or Volterra. Just I will repeat. So today what we are going to see, if differential equation is given, how we are going to form, that is how it is going to be converted, how it is going to be converted into linear integral equations of two types, whether it is a Fredholm or Volterra. So that can be identified by using the boundary conditions. Whether boundary condition, it's a boundary variable, it is only given on the boundary or it is given in the initial. Based on that we can identify that. So as I did in the previous, I won't be giving the option. So just we will try to solve a given problem. Then after that, we can identify. So how from the solution itself we can go with it. We can proceed with that. So instead of going with options, so just I have converted the problems, and then we will approach the problem, and then we'll try to solve. So question is, convert the following, just I'm writing DE, differential equation, to corresponding, just I'm writing integral equation, corresponding integral equation. So this is what we are going to see. So as a base, if we see, we need two results. So one is Leibniz rule, okay, that you may be knowing. The other rule is integral a to x, integral a to x, f of x dx or dx square. So that is nothing but integral a to x, x minus t into f of t dt. So what is the generalized form? Integral a to x, integral a to x, like that we have integral a to x f of x dx power n, which is equal to how many times? We are having n times. We are having n times. So what will come? 1 divided by n minus 1 factorial integral a to x, here x minus t the power n minus 1 into f of t dt. So here we are having two terms. So that means what will happen? 1 by 2 minus 1. So 1 factorial. So that is what we got, 1 factorial. And then n is 2. So 2 minus 1, that is what we got. So no need of writing that. So that is what. Suppose if you are having dx means what will come? 1 by 3 minus 1. That is 2 factorial integral a to x, x minus t the whole power 3 minus 1. That is x minus t the whole square into f of t dt. And then the other result, what I said is, you have to remember Leibniz rule. So I'll be giving the Leibniz rule when we are going to approach that. So just we are going to solve our first problem. So convert the following differential equation to corresponding integral equation. The question is, problem number 1. I will take a simple problem. Y double dash plus y is equal to cos x, given condition y of 0 is equal to 0 and y dash of 0 is equal to 1. Okay, so question may be like, identify the integral equation which will be derived. Okay, whether you will be getting Volterra or you will be getting Fredholm. So what I said, based on the boundary condition, we can identify. So what I said here, what is the condition they have given? Y of 0, y dash of 0. So that is only on initial. So if it is initial means surely it is going to be an Volterra type. So that these and all how we can identify. And then they may be asked either it's a first type or a second type. Okay, that may be there. And then what will be the solution, they may ask. Okay, and then what will be the integral equations? Like that we can have the equations. That is a sequence. Like here we are having differential equation. Okay, the option may be like identifying the type. Identify the type. That is either it is a Volterra or Fredholm. And then identifying the kind. Either it is a first kind or second kind. That will be based on v of x. V of x is equal to 0. V of x is equal to 1. And then they may be asking the solution, and then they may be asking what will be the integral equations. So these are the type what we can discuss. So y double dash plus y is equal to cos x. So this is the differential equation. So now we are going to convert this differential equation into an integral equation. So either it is of type Volterra or Fredholm, but we identify that it is Volterra. So now we'll try to solve. So since it is a function of x, so just I'm rewriting this as y double dash of x plus y of x is equal to cos x. So there are two methods. Okay, we can approach. One is by assuming a function as a pi of x, or by integrating. So I will do by both way. So first we will go by integration. So by integration means, so integrating with respect to x, and then with the limits, because we don't know about the limits. Why I'm saying? Because here y of 0 is given, y dash of 0 is given. Only the initial condition is given. So that means I can know that the lower limit is 0, but I don't know what is the upper limit. That means I'll be choosing the upper limit as x. So this is what the limits. So now I'll be integrating. So that means what I will get y double dash of x plus y of x is equal to cos x. So integral 0 to x y double dash of x dx plus integral 0 to x y of x dx is equal to integral 0 to x cos x dx. As I said in my previous session, you should know what are the basic integrals. Then it will be easy. So what's the integral of y double dash of x? It will be y dash of x. So you know how integration and differentiation are related to each other. So y double dash of x. What is the integral of that? This will be y dash of x. What is the limit? 0 to x. Plus here we don't know about what the function is, and then don't try to integrate. So that means this will be as such the same. So 0 to x y of x dx is equal to, this is what result in that integral equation. So this is going to result in that integral equation. So is equal to integral of cos x. What's the integral of cos x? What is the integral of cos x? Sin x, limit is 0 to x. Now we'll substitute the limit. So what is the upper limit here? X. So that means y dash of x. What is the lower limit? 0. So that means y dash of 0. Plus, don't change here. You keep as such. This is y of x dx. Now we have to substitute the upper limit. What is the upper limit? Sin x. What is the lower limit? Sin 0. What is sin 0? 0. So we will leave as such. So now here if you see y dash of 0 is there. Y dash of 0 already we are having the condition y dash of 0. What is the y dash of 0? It is 1. So that means that is equal to 1. If I put 1, so since y dash of 0 is equal to 1, so that implies y dash of x minus 1 plus integral 0 to x y of x dx is equal to sin x. So now y dash of x plus integral 0 to x y of x dx is equal to sin x plus 1, because that minus 1 will come to the right hand side. So now actually we are converting the differential equation into an integral equation. You may be asking when we have to stop the procedure. Okay, so actually our aim is to convert the differential equation into integral equation. So if you see, whenever that differential term get reduced, okay, until that we have to do. So here we are having y dash of x. So that means again we are going to integrate. So again integrating with respect to x. What will be the limits? The same, 0 to x. So limit will be same, 0 to x. So now if we do the integral, means what will be getting? Integral of y dash of x dx. What is the limit? 0 to x plus here 0 to x, again 0 to x y of x dx dx, because we are integrating with respect to dx. So which is equal to, here we have to integrate 0 to x 1 plus sin x dx. So now we are having y dash of x. We have to integrate. What's the integral of y dash of x? Y of x. So y of x limit is 0 to x plus. So if we see here, we are having 0 to x, 0 to x, y of x dx dx. So already we are having a result on that. What is that? Integral 0 to a to x, a to x, f of x dx dx is equal to integral a to x, x minus t into f of t dt. So we can change a function also. So that means I can write this as integral. What is the lower limit? 0. What is the upper limit? X. So and then function will be x minus t into y of t dt or pi of t dt. Even we can assume. So here we chose as f of t. So that we can put whatever it is. So we have to follow the same variable. So which is equal to, now we have to integrate the right hand side. So what will the integral? So integral of 1 is x. What's the integral of sin x? Minus cos x, the limit is 0 to x. So now here we have to substitute the limit. What is the upper limit? X itself minus lower limit y of 0 plus integral 0 to x minus t into y of t dt is equal to upper limit x minus cos x. Lower limit, if we substitute lower limit, 0 will come, cos 0 1, upper limit minus lower limit, so plus 1. So already we are having what is y of 0. So that is what I said, boundary condition. What is y of 0? It is 0. So that means y of 0 will get cancelled. So this is 0. So no need to consider. So that means what will get? Y of x plus integral 0 to x minus t into y of t dt is equal to x minus cos x plus 1. Or whether we have to proceed again, no need. So actually what is our aim? We are converting the differential equation into integral equation. So now you check whether, now you see here whether any differential term is there or not. So don't say dt. We don't have any differential equation, either y dash of x or y double dash of x or like that. So that means this is the required solution, but we can convert in the required format. Okay, what is that required format? So we can write this as y of x is equal to x minus cos x plus 1 minus integral 0 to x minus t into y of t dt. So that's it. We got a integral equation. So what is the limit? 0 to x. So that means what type of linear integral equation is this? Limit is x. So that means this is a Voldra type. Okay, and then what is the v of x? In place of u we are having y. Okay, and then what is v of x? V of x is 1. So that means this is second type. So that means this is second type. And then f of x is not 0. So that means it is not an homogeneous. So like this we can proceed. What is the lambda here? Lambda is minus 1 because lambda will be reflected here. And then what is a kernel? Kernel is equal to x minus t. So like that we can do all the classification. So we can't able to identify how we can. I will give you the form. What is that? V of x into u of x is equal to f of x plus lambda into integral 0 to x kernel of function into u I have given. So u of t dt. Okay, now we can compare. In place of u we are having y. So that means y. What is v of x? V of x is not here. That means it is 1. So v of x is 1. Okay, so v of x is 1 means that is the second type. Okay, what is the function f of x? X minus cos x plus 1. And then what is lambda? So here lambda is minus 1 since we are having minus. And then what is the kernel? X minus t. So this is how we can do the classification. So now even what we can do, now we are having an integral equation, even we can find the solution. What is the solution for this? Okay, but that is not our part. Already we did it. This is what we did in the last session. So this is one of the way how. So that this is how. So they will give you a differential equation. Convert the differential equation into what will be the suitable differential equation for this. What will be the suitable integral equation for this differential equation? This may be the question. And then if it is a part C means if this is the differential equation, which of the following are true or may like that. So that means either they may give you the type either Voltra or Fedron, or they may be giving like what kind of that is a either it is a first kind or second kind, or they may be giving what is the kernel, or they may be giving the solution like that they can. So this is way one of the way. Okay, so now we'll do one more. So this is my second problem. So problem number 2. So find the corresponding integral equation to the differential equation y double dash minus 5y dash plus 6y is equal to 0. So given condition is y of 0 is equal to 0 and y dash of 0 is equal to minus 1. So now what I'm going to do, I'm going to do the second approach. What is the second approach? Just by assumption. What is the assumption? So for assumption, which is the highest derivative, which is the highest differential form you have, so that we have to assume as an equation, that is as a function, then we have to proceed. So just I will rewrite this. This is y double dash of x minus 5 y dash of x plus 6 y of x is equal to 0. So just I have rewritten that. Okay. So again they are given a condition. So just check whether it is an initial or boundary condition. So here they are given only under 0 and 0. So that means they are given only initial. So that means what will be my resultant? Volterra linear integral equation. Okay, and then I can, from here I can't identify what is the type and all. Okay, so that for that we need a solution. So here I'm going to go up, my solution will be a second approach. So what is the second approach? Which is the highest form of differential term y double dash. Suppose y triple dash is there, means you have to assume that y triple dash. So whatever highest derivative is there, so just we have to assume that as some function. So now let assume y double dash of x is equal to some phi of x. So y double dash of x is equal to some phi of x. So y double dash of x is there. So that means this is my differential equation. So this is my differential equation. So here what are the terms I need? So y double dash of x I need, y dash of x I need, and then y of x I need. If I am able to find all these from here, then that will be my solution. So this is what we are going to do. So y double dash of x is there. I want y dash of x. How I can get? So by integrating. So integrating. So integrating, as usual, limit boundary is only the boundary is given, 0 and 0 is given. So that means our limit will be 0 to x. So integrating, okay, integral 0 to x y double dash of x dx is equal to integral 0 to x phi of x dx. Once if we practice, no need to put all this, because directly we can write what is the integral of y double dash of x. Directly we can put y dash of x. Suppose if you want the limit, means directly we can put 0 to x. Similarly, if I want to integrate y dash of x, no need to put integral and all. Directly we can put y of x, and then my limit will be 0 to x. Directly we can write all these things once if you get practiced. So now I am going to integrate. What's the integral of y double dash? Y dash of x. So y dash of x, what is the limit? 0 to x is equal to, don't try to integrate, because this is what is going to reflect in our equation. So that means this will be same 0 to x phi of x dx. Now we have to substitute the limit. So here what will come? This is y dash of x upper limit minus lower limit y dash of 0 is equal to right hand side integral 0 to x phi of x dx. Okay, so now we are having y dash of 0. So just we need that boundary condition. What is the boundary? Y dash of 0, what they have given? Y dash of 0 is minus 1. So here I have to substitute minus 1. That means what will come? Y dash of x minus of minus, so plus 1 is equal to integral 0 to x pi of x dx. So now we have reduced into y dash of x. So y dash of x is equal to integral 0 to x pi of x dx minus 1. So now we can see. So initially I chose y double dash of x. So that means I can write what is y double dash of x. Now I got what is y dash of x. So as I said in the earlier, so what are the terms we need? We need y dash of y double dash of x, we need y dash of x, we need y of x, we need all these three terms, because that is what reflecting. So based on this, suppose if my y of x is not given in the problem, means that means y double dash of x and y dash of x is enough, and then I will approach what is the solution. So based on that, what are the terms they have given, based on that. So as for this problem is concerned, we need y double dash of x, and y of x is also. So that means I need this result. So just I will make. Now again I need y of x. How to get y of x? Again integrating with respect to x. What will be the limit of x? Same 0 to x. So that means I have to integrate. Shall I write directly? So if I write directly, means what will come directly here? Y of x. What will be the limit? 0 to x is equal to right hand side. Don't try to integrate the first term because that is what our function phi of x. So 2 times, so dx square directly I can write, or dx. So minus 1 is there, so that means we have to integrate that minus 1. So minus 1 with respect to x, with respect to the limit 0 to x. So that means what will come? So integral of 1 is x, that means x, 0 to x, upper limit is x, minus, so that means what will come? Minus x. So now here if we substitute the limits, what will come? Y of x, lower limit is y of 0, so minus y of 0 is equal to, so this is integral 0 to x, this will be integral 0 to x, phi of x dx square minus x. Again we need boundary condition y of 0. What is y of 0? They have given y of 0 is 0, so that means that is going to get cancelled. So that means this will get cancelled. So y of x is equal to integral 0 to x, integral 0 to x, phi of x dx minus x. So that means what are the required terms? Y double dash of x, y dash of x, and y of x, all these I got. So that means all these you will be getting. Okay, that means now we have to substitute in that given differential equation. So just I will rewrite the differential equation and then I will be proceeding. So what's the differential equation? Y double dash of x minus 5 y dash of x plus 6 y of x is equal to 0. So what is y double dash of x? We got that, we assumed that as phi of x minus 5 into y dash of x. What was our y dash of x? Y dash of x. Okay, so minus 5 integral 0 to x phi of x dx minus 1 or plus 1. Yes, minus 1 y dash of x minus 1 plus 6 into y of x. What is y of x? We got integral 0 to x, integral 0 to x, phi of x dx minus x is equal to, don't forget, is equal to 0. Okay, so just we are resubstituting whatever we got. So now just we need to simplify. So phi of x minus 5 into integral 0 to x phi of x dx, this will be plus 5. Okay, plus 6 into, so what is the first term? Integral 0 to x phi of x dx. What will be that? That is nothing but integral 0 to x minus t into phi of t dt minus x is there. This minus x is equal to 0. So this is what the result already we know. Double integral of 0 to x phi of x dx is equal to, how many terms are there? That divided by factorial 1 divided by n minus factorial x minus t the whole power n minus 1 into the function phi of t. So that's it. We got, just we have to simplify this. So phi of x, okay, minus 5 into integral 0 to x phi of x. So since here I am having phi of x, so dx, so just I put this as phi of t dt because variable can be changeable. So plus, that is one of the property under integrals. So plus 5 plus 6 into integral 0 to x minus t into phi of t dt minus 6x is equal to 0. So 5 of x plus, just I am taking here the integral phi of t common, so that means what will come? Integral 0 to x. Okay, so here this is 6x minus t, so 6x minus 6t. So here 6x minus 6t, so here minus 5, so minus 5 of phi of t dt. Okay, hope this will be clear. So here we are having a 6, so that 6 will be multiplied here, that means 6x minus t, 6x minus 6t, and then here we are having minus 5, so that is what reflecting here, minus 5, and then this integral is common, so that is what I have written that. So we simplified the first part, and then remaining constant are there. So what is that? Plus 5 minus 6x is equal to 0. So just we will rewrite 5 of x is equal to, when this 5 minus 6x comes this side, that means this will be 6x minus 5. When the entire term goes that side, that means integral 0 to x 6x minus 60 minus 5 phi of t dt. That's it. So again v of x is 1. Okay, so this is what u of x. So that means here v of x is in the form of 1. So v of x is 1. So that means again second type. So since here we are having a function f of x, so this is a non-homogeneous. If this will be 0, then that is a homogeneous. So this is what a kernel, and then this is lambda is equal to minus 1. Again this can be solved. Okay, again we can find the solution for this. So this is our second problem. So we'll go for one more problem. So there we'll be having some variables. Suppose, so here I've taken differential equation without there is a constant coefficient. Suppose if you have a variable coefficient, then how the approach will be? The same way, the same process. So now this is my problem number 3. Just I'll write the equation. What is the differential equation? Y double dash minus 2x y dash minus 3y is equal to 0. So y of 0 is equal to 1, and then y dash of 0 is equal to 0. So again they are given on initial, so that means again it is going to be an ultra type. Okay, so just I will rewrite the equation. So here the difference is, here we are having a variable coefficients. That is what the difference. So again I can, this is rewritable as y double dash of x minus 2x into y dash of x minus 3 into y of x is equal to 0. So since this is the highest, so we can go by the assumption. So y assumption method will be easy in this case, because here we'll be having 2x. If you have to integrate, means you have to go by integral by parts, because if I am going to integrate the second term, so integral of the second term is 2 into integral 0 to x into y dash of x dx. So that means how this will be integral, because it's a function of x, it's also a function of x. So that means in this case I have to proceed by integral 0 to x into d of y of x. That means this is of integral type, integral by parts, u dv. So it may be time taking. So in that case what we can do, we can go by that same method phi of x. So what we can assume, let y double dash of x is equal to phi of x. Let y double dash of x is equal to phi of x. Okay, so integrating. So here I'm going to do directly. So integrating. Okay, what will be the one time integral? Y dash of x minus y of 0 is equal to integral 0 to x phi of x dx. How we are getting this? Integral of y double dash of x dx. So y double dash of x dx. What's the integral of y double dash? Y dash of x. Okay, what is the limit? Limit is 0 to x. So 0 to x. What will be the upper limit? Y dash of x. What is the lower limit? Y dash of 0. So that is what I have written directly. So now we will substitute that condition. What is y of 0? Y of 0 is 1. So that means what will be getting? Y dash of x is equal to, this is minus 1, when that minus 1 comes inside. So 0 to x phi of x dx plus 1. Again, how to approach? So here y double dash of x is there, y dash of x is there, y of x is there. That means compulsorily we have to find y double dash of x, y dash of x, and then y of x. So we have to find all these, and then we have to approach. Suppose if you find easier method, then we can apply that. Suppose directly some kind of terms are reducible, means directly we can apply that. So again we have to do the integral. So again integrating, again I'm going to do the integral directly. So again, if you do the integral, what will come? So integral of y dash of x dx. If you do the integral, what will come? This will be y of x. What will be the limit? 0 to x. That means y of x minus y of 0. Okay, so that means this will be nothing but integral of y dash of x is y of x. So just directly I can write y of x. What is the limit? 0 to x. So that means upper limit is y of x, lower limit is 0. So right hand side we have to do the integral. Already one integral is, so that means it will be double integral 0 to x phi of x dx into dx. Plus second term we have to do the integral. That means integral of 1 is x. So that means x 0 to x. Integral of 1 dx with 0 to x. Integral of 1 is x 0 to x. So that means upper limit is x, lower limit is 0. So that means we'll be getting x. So just I have written directly. So that's it, we got. So y of 0 we need. What is y of 0? It is 1. So here I have put y dash. Okay. So here I have to put y dash. What is y dash of 0? Y dash of 0 is 0. So sorry, by mistake. Okay. I will repeat. So y double dash of x, we have to integrate this with respect to x. So this is what will happen. If you do directly, what will happen? Sometimes we will do mistakes. So better at the initial point. So what's the integral of this? This will be y dash of x. What is the limit? 0 to x. So that means y dash of x minus y dash of 0. So this will be 0. So that means here we won't get any right hand side. Okay. So that means here there won't be any right hand side term. Okay. So just I came to identify only from the boundary condition. So that is why the boundary condition plays a key role. Because by mistake what I took y of 0. So that is what. So now here y dash of 0. Here y of 0. Y of 0. What is y of 0? It is 1. So that means y of 0 is 1, means here y of x is equal to double integral 0 to x phi of x dx. That is y of 0 is what? 1. Y of 0 is 1, means minus 1. So plus 1. So that's it. I think we got all, whatever the term we need. Okay, now we can go for that function. What is the problem? Y double dash of x minus 2x into y dash of x minus 3 into y of x is equal to 0. So this implies what is y double dash of x? We assume to be 5 minus 2x into what is y dash of x? We got y dash of x is integral 0 to x phi of x dx. Integral 0 to x phi of x dx minus 3 into y of x. What is y of x? We got the previous step, that is integral 0 to x phi of x dx plus 1, which is equal to 0. So here what I assumed, all the right hand side happens to be equal to 0. Suppose in case if we have the function, then we have to put according to that we have to proceed. That's it. So just we need to simplify. So phi of x minus 2x. Just I can rewrite this as integral. I will write this as phi of t dt minus 3. So this is nothing but what? Integral 0 to x minus t into phi of t dt minus 3 is equal to 0, because minus 3 is multiplied. So this will be the reduced form 0 to x, that can be written as. So now we can take phi of t common in the second and the third term. So that means phi of x plus integral 0 to x. So here this will be minus 2x. Here this will be minus 3x plus 3t phi of t dt. Okay, so that means I've written all these terms. So here minus 2x, that is what minus 2x. This minus 3 is common to both. So that means minus 3x plus 3t, minus 3x plus 3t. So and then what is the last term? Minus 3. So minus 3 is equal to 0. Okay, so therefore simplifying 5 of x plus integral 0 to x. This will be 3t minus 5x. Phi of t dt is equal to 3. So 5 of x is equal to 3 minus integral 0 to x, 3t minus 5x into phi of t. That's it. This is what the integral equation. That is. Again, we can identify what is the kernel, whatever it is we want. Okay. So don't do that mistakes. Here y double dash. Once if you do the integral of y double dash, it will be y dash. So that means y dash of x minus y dash of 0. So what is y dash of 0? It will be 0. So that means that will be eliminated. And then again from y dash of x, if you do the integral, we will get y of x, and then just to be possible. Okay. So just I will give you 1 or 2 problems we can practice, so that I will be getting some idea. So just try to solve this. Y double dash of x minus 3 into y dash of x plus 2 into y of x is equal to 5 sin x, with the conditions y of 0 is equal to 1, y dash of 0 is equal to minus 2. So same way, same process. So with this, I will end this lecture. So just I will recall whatever we have done. So in my earlier, just we given the introduction about what is a linear integral equation. So linear integral equation are of a general type. What is the general type? V of x into u of x is equal to f of x plus integral a to b k of x comma t into u of t dt. So there are so many functions. What are unknown? What are the known? What is lambda? So that you should know. And then based on what the classification is done. Based on v of x, what is the classification? Based on f of x, what is the classification? So that may be under part C. Okay. And then how to solve the solution. This is what we did in the last class. Either by from the solution we can approach the problem, or by assuming, that is what a successive approximation method. Either we can assume 0 as a solution, that is the initial approximation, then first approximation, second approximation, like that. Once if you proceed, you will get a pattern. From there we can identify. So this is what a successive approximation. And then here in this today's class, if differential equation is there, then how the differential equation can be converted into an integral equation. Again, here the question, here the thing is, if I assume y double dash of x is equal to phi of x, and then if I proceed means I'll be getting a solution. If I do the integral, I may be getting a different solution, but which may be suitable based on the Leibniz rule. By applying that, we can identify which will be the solution and all. That's also a part. Okay, so with this I will end this. Thank you.
Thank you, sir. Thank you so much, sir.
In the step 1 integration, y dash of x. Satish Kumar, thank you. In the step 1 of integration, it would be y dash of x minus y dash of x. Thank you, ma. That's what I did. Just I took directly. So these are all type of mistakes. But anyhow, that can be identified from where while substituting the limits and all. Thank you, Satish.
Thank you, sir.
Thank you. Hope you got some kind of information. So just you can post in that comment itself. Okay. Thank you, Krishna sir, and thank you, Rajshekhar sir.
Thank you, sir. Thank you. I need to multiply thank you word 1,000 times to match it with your report, sir. We wish to express our gratitude to our resource persons for being with us on this event. Your presence and gentle words are a source of encouragement for all of us, sir. Thank you so much, sir. I would like to thank Professor R. Venkatramanan, Head PG and Research Department of Mathematics, for organizing this C4 workshop. Our next C4 program will be held on tomorrow at 11 a.m. Thank you.